Hi everyone, welcome to statics course. Today chapter is equation of equilibrium. Let's look at the chapters. Before we go to the chapter 5.3, let me review what we done so far. So far we covered a lot of chapters, and the rest of the chapter is equilibrium of the rigid body, structural analysis, friction, and the center of gravity. So the remaining exam and the quizzes are here. So we have 3 quizzes. We have 2 homework left, and we have 1 midterm left, and we have 1 final exam left. So total will be 3 plus 2 plus 1, which is 6 plus 1. So we have 7 exam and homeworks are left. So after chapter 6, we will have a midterm exam too. And after chapter 9, we will have a final exam. I thought about how to update our grading system since we changed the lecture format from face-to-face to the online lectures. I want to fairly evaluate your achievement for all the students. So here we have some gradings, which is exactly the same. But let me add this part. There is an extra credit part. What I'm thinking is that since this is fully online, when you finish the exams, such as quizzes or midterm or final exam, I want you to submit your handwritten solving process after your midterm exams. So I will make a link so that you can click the link and submit your handwritten solving process so that you can get a partial credit as well as you can get an extra credit. This is 1%. 1% is pretty big. So I want you to submit your solving process. This grading system will be effective from March 26th, which is tomorrow. For the attendance, we already record more than two months record here. So I think it's pretty sufficient. So attendance rate is still same. Course folder. Some students have a question about the course folder. In this case, please email me individually about your midterm one and all the quizzes that I gave you. Or you can just took the front page that's showing your name and send me the photos. Then I will count that you submitted the course folders. So about the online exam, I believe many students have some questions or curiosity how the question will be appeared in terms of what kind of format that I'm going to choose. I'm thinking that I can use multiple choice questions or the mixed style with the multiple choice as well as the fill in the blank, what we usually did. So all the exam must be delivered through online with a blackboard, and they are on all open book test. Okay, so you can check the book, it's fine. But what I'm thinking is that 70% of the questions is from my slide. It's existing questions, I'll say. The other 30% of questions will be shown. This is new questions, which is we didn't solve the problem. But if you know the contents very well, then there will be no issues. You can solve the new questions. Okay, so 70% existing and 30% new questions. About the exam date, I'm thinking that our regular class hours are Tuesday and Thursday, right? So I want you to start the exam at 11 a.m. It could be either Tuesday or it could be either Thursday. It depends, but I will definitely announce at least a week before on the Blackboard. Like I said, after finishing any test, including quizzes or even homework, midterm and final exams, just photograph your handwritten solving process and submit it through the Blackboard for an extra credit. I know that since this is an online exam and you may need to take more time. So I would like to give you more extended time, but the number of questions should be very similar. So there is not too much change the number of questions on the midterm exam 2 and the final exam, but you have extended time for more flexibility. So for example, I would like to give you more than 1.5 times. Okay, so for example, previously we have a quiz that is limited to 20 minutes quiz. Okay, there was a time limit, but from now on you have 30-minute quizzes. 30 minutes for quizzes. How about midterm? Midterm was usually 75 minutes, but now it has been extended to 113 minutes. After you finish the midterm and the quizzes, I want you to submit your solutions. I will give you an additional 30 minutes for this uploading time. I know some students have some problem, struggling to find the link, internet access issues. I understand that, but 30 minutes is pretty good enough. You can just take the photo of your solutions and upload your work on the Blackboard if you want extra credit or partial credit. This is a tentative grading systems, but if you have a really concern about this updated systems, just let me know. I will consider your opinions. But please email me by this weekend, okay? So that we can mutually agree that this grading system, then we can keep going. Like I said, I will consider relative grading system as well as the absolute grading system. So no matter what your ranking is, if your score is greater than above 90, then you get A grade. Okay. Also, if your score is low but your ranking is very high, then you get a grade. I think it was a top 25%. All right, so let's move on. So we have one learning goal today. Apply equations of equilibrium. So you may remember we learned this concept last class. Sigma F should be equal to 0. Sigma moment should be equal to 0. So these two things are main equation we have to use. In 2 dimensions, it's pretty easy, guys. Sigma fx should be equal to 0. Sigma fy should be equal to 0. That means there is no translation. This one means there is no rotation. So this is the rigid body. If this rigid body is unstable, then these equations should be satisfied. Well, this is interesting one. So if you look at this one, sigma fx is equal to 0, and sigma moment a. Oh, okay. So we learned this one that horizontal axis should be equal to 0, and the vertical forces should be equal to 0, and any point at point O should be equal to 0. How about these equations? If the horizontal forces are all equal to 0, okay, no matter what the force Fy equal to 0, if there are 2 points, point A and point B, if the moment at point A is equal to 0 and the moment at point B is equal to 0, then without satisfying this condition, sigma fx, fy equal to 0, then these three equations is good enough that the rigid bodies are stable. Same thing, no matter what the force fx and force fy, if these three conditions are satisfied, all the moment at point A and point B and point C are equal to 0, then there is no translation and no rotation. Okay. So let's look at why. If all the horizontal forces are equal to 0, that means, well, if there is some forces are acting horizontally, and this is 100, let's say this is 100 Newton, then they are equal, all the summation of the forces are equal to 0. And the moment at A is equal to 0. So moment at A, here we have these forces. So this one create the moment about point A. That is the what was that? That was a clockwise rotation. Okay, that was a clockwise rotations. But this one is equal to 0. What does it mean? So force is not here. That means the force is here, which is collinear. So there is force, but the moment at point A should be equal to 0. Okay. What about the moment at point B is equal to 0? Here. Oh, this one create the forces. This one create a moment. Okay. But since the perpendicular distance for the two forces are equal, so this one create the counterclockwise rotation, this one create the clockwise rotation. So that means any point point B, the moment should be equal to 0. When you solve the problem, please draw the free body diagrams. So first step, there are several steps. The first step is to show the XY coordinate axis. You know this. So this is positive x-axis direction and this is positive y-axis directions. And the outline shape. Show all the forces and couple moments. Label all the loadings. And if you have unknown forces, then you have to assume the direction of the unknown forces. Indicate the dimensions. Then apply the equilibrium equation, which is sigma fx equals 0 and the sigma fy equals 0. That's pretty much it. When you solve the problem, you may want to apply the moment equation first. You may see there are unknown variables when you solve the problems. But if you apply this equation first, before you apply this force x equals 0 and fx y equals 0, but this one, if you solve this one first, then some cases you can easily find the unknown forces. You can change the orientation if you want. For example, this is the horizontal force x, positive axis, right hand direction, and the upward direction is positive y. But you can change, it's really up to you. You can set the opposite way. This is positive x and positive y, or you can tilt these orientations. This is positive x and positive y. It's really up to you. Whichever is useful to solve the problem. If you have a negative scalar, this is pretty important, guys. If you solve the problem and you got a negative values, what does it mean? That means your assumption on the direction was wrong. So you have to convert, you have to change the direction to the opposite directions. Okay, so for example, you assume that, okay, this is the we have unknown force B, but when you solve after you finish the solve the problem, you got a negative value. Oh, B is negative 100 Newton. What does it mean? So that means the direction is opposite and this is 100 Newton. All right. So this is important. We will see some cases during the examples. So question, determine the horizontal and vertical component of reactions. Determine the horizontal and the vertical component of reactions. Okay, so do you remember the support reaction that we learned last class? There are support reaction. Because if you look at here, point A and point B are supported by, this is a rocker. This is a rocker. And this is pin jointed. How many unknown forces are associated at the pin joint, guys? How many forces unknown? To support, because why? If you look at the pin joint, there are restrictions for the vertical direction as well as horizontal direction. How about the rocker case? Rocker has only one support for the y directions. There is no restriction for the horizontal direction for the rocker case, but the pin, we have to think about the horizontal unknown support reactions by this pin. Okay. So let's find the reactions. Like I said, we have to draw the free body diagram first. Let's draw the... my drawing is not so great. Please understand this. B A. There is a D. Okay, let me change the color here. I think I can change the color. Okay, so like I said, there is only one support reaction for the A because this is rocker. The pin joint, we have a two support reaction which is unknown. Let's say this is BY, and we don't know the direction, but let's say this is the BX. The orientation is right hand direction is positive X and above is positive Y directions. Okay. Oh, by the way, finish the writing here. And this is 100 Newton. Okay, that's it, right? That's it. Let's apply equilibrium equation here. Sigma fx should be equal to 0. Sigma fy should be equal to 0. Sigma moment, any point O should be equal to 0. For the x-axis, what is the component here? We have bx, which is a negative value, b direction bx. How about this one, 600 Newton? We can say that this is 45 degrees, so this one you can decompose. This one is 600 times cosine 45, and that's it. I think that's it. Wow, this is a pretty easy case. This is 0. How about the y component? Okay, there's ay. Okay, here we have ay and negative 600 sine 45. Okay, and we have another external forces which is negative 100 Newton here, minus 200 Newton plus by, and this one should be equal to 0. Any point, the moment, the sum of all the moment should be equal to 0. Let's choose a point A, okay? Because we have unknown forces at point A, so we don't need to think about this ay for the moment at point A. So we can, I think we can calculate easily. So as well as the bx does not affect to the moment at point O because these are collinears. So I think, oops. Okay, let me redraw. Okay, Okay. So let's choose the point A. That makes our life much easier. Let's see. You can see that. Oops. Sorry, guys. Let's go back. For the point A, we know that these force and these force are creating clockwise rotations at point A. This one create clockwise rotation. This one create clockwise rotation. This one create counterclockwise rotation. So let's look at the clockwise rotation. The sign is minus. So minus 600 cosine 45, which is the horizontal forces, and times the distance should be 0.2 meter. This one is negative sign. Okay. Another one is minus 600 sine 45 times the perpendicular distance in this case is 2 meters. This one. And we have another clockwise rotation, 100 Newton times 5 meter. Another one minus 200 times 7 meter. And we have a last one, which is a counterclockwise rotation, by times 7. This one should be equal to 0. Okay, so from the first equation, this one, we can directly find the bx, which is 600 times cosine 45. So bx is 424, which is a Newton. From the third equation, we can find the by. Once we find the by, then we can find ay. Okay, let's find the by. Let me see. I think I have the examples in here. by should be 404.8 Newton. Then ay, you can calculate. This is 724.3 minus